And actually in this data science community, it's not so common to produce very clean code, mainly because usually we need to try a lot of approaches and things during like very short period of time. But I still want to force myself to write cleaner code, and that's why I'm here. And today I want to present one chapter from this Robert Martin's book about classes, like how to write clean classes. So probably most of you know this. So in this object-oriented programming, if you have an object and then a class, basically this is a template or a blueprint that describes what behavior and what state that this object supports. So in this case, this dog class, it has these states: breed, size, age, and color, and it has this behavior: eat, sleep, sit, and run. So there are several basic principles that we should follow when we are creating classes. One is this class organization. So in Java, it's like usually this first we in the class declaration first. Oh, I'm sorry. Is there a pointer also? Right? No. Okay. So usually the first goes the list of variables, and it follows by the list of methods of this class. And also we should follow this step-down rule, and basically it states that the code should be readable from top to bottom, descending one level of abstraction per function. So what it means, like, let's have a look at some bad examples. For instance, here we have this function make breakfast, which is calling this at x, cook and serve. And in principle, this make breakfast should go first, and after that, all these private methods that it calls. So this is example of this wrong order. In this example, everything looks fine, but there are too many details. So, for instance, these two could be hidden in some additional functions. So there is this mixed level of abstraction. And in principle, it should look like that, and then it follows this step-down rule. Another principle that is good to follow when you are writing classes is this encapsulation. So it means that in principle, we want the variables to be private and to be accessible only by these getter methods. And if you want to set this variable, there should be additional this setter function, set function. So if you have this encapsulation in your code, it allows you to better control the class attributes and methods. Also, you can make the classes read-only or write-only. And also it makes the programmer easier to make some additional features and changes, and to be sure that it will not influence other parts of the code. And of course, it also increases the security of the data. But there is one important note that even though in principle we want to follow these guidelines, tests they rule anyways. So if some tests they need to access some private variable, then we need to do something to make it happen still. The other principle is that classes should be small, but in case of classes it's a bit hard to define, like what does it mean for class to be small. And author of this book, he provides these hints that, for example, instead of counting number of lines or number of methods, we need to count number of responsibilities in the class, and the less responsibilities each class has, the better. And also there is some kind of these check rules that, for example, you should be able to give a name to a class such that it will describe the responsibilities that it fulfills. And also you should be able to write a brief description of the class in about like 25 words, avoiding if, and, or, a but. And if you cannot do that, then probably your class is too big and you need to split it. And all that leads us to this single responsibility principle, which states that a class should have only one reason to change. So let's have a look at these examples from the book. Even though these both classes have quite few methods, this class, it takes care only of the versions in the code, but that takes care of the versions and as well as these Java components. And so it means that there are at least two reasons to change in this class, and in principle it should be split into two at least. The other principle is this cohesion. It states that the class should have small number of instance variables, and methods should use at least one or more of these variables. So this is the example of a very cohesive class. So it has only two variables, and only one of the methods is not using both of them. So this is the example of really cohesive, very cohesive class. And if you will start to follow this cohesion principle, probably you will find out that it results in many small classes instead of one big. So for example, let's say you have a big function and you want to split it into smaller ones. And then you realize that in order to split it to two functions, you need to give these variables as an arguments to another one. So one thing you can do is you can make these variables as instance variables. But then at some point you'll find out that only like several of your functions are using the same instance variables and some other are using completely different. And at that point, when you realize it, then you should probably split your class into smaller ones. The other very important principle is called this open-closed principle. So it can be explained in this way. For example, let's say you want to create a class that will calculate the area of some object with some shape. Then the easiest way, for instance, you can write something like that, and then you can write a function that will calculate the area of rectangle. But what if then you want to add this circle, and you want to add this feature that it will calculate also the area of the circle? So this situation means that your class is open for change. So whenever you want to add some additional feature, do some change, you need to like open this class and modify it. And potentially it can lead to some other part of the code to be broken. So we need to avoid these kind of situations. And to fix this in this case, for example, what we can do is we can create this interface shape, and then we can implement this area calculation separately for rectangle and for the circle. And basically it makes our area calculator independent on the details of the implementation. And so whenever you want to add some additional feature, you don't have to change the area calculator, and it makes the class closed for the change. And so this leads us to these two principles. First, this open-close principle. It says that classes should be open for extension, but it should be closed for modification. And the other, this dependency inversion principle, it says that classes should depend upon abstractions, not on the concrete details of implementation. So basically, to summarize, all this leads us to these, 7 principles of writing clean classes. So first, that it should be like organized properly, then it should follow this step-down rule. It should follow the encapsulation, meaning that you should keep your variables private. Also, your class should have only one reason to change, which is this single responsibility rule. It should be cohesive, so that it should have few number, like small number of instance variables, and most of the functions should use them. Also, it should follow this open-closed principle and dependency inversion principle that I was talking just a slide ago. And from all that, basically, this is kind of the take-home message that getting software to work and making software clean, it's like two very different activities. And quite often, most of us, we don't have time, or we are too lazy to kind of, once our software works, to invest time to make it clean and to split our big classes into small ones. But maybe we should invest in that. And actually, there is also an opinion that if you have like a few bigger classes, then from one point of view, it's maybe easier for you to see the logic, how all this, see the big picture, how all this thing works. But comparing to if you have a lot of small classes and you need to go from one to another to understand how they are connected, and maybe your tool would help in this case a lot. But on the other hand, maybe if you have a few bigger classes, then you unnecessarily have to go through details that you actually don't want to know and to learn, and to change one tiny small thing, you need to go through huge bunch of code. And basically this is analogy. So what do you want to have this toolbox with a lot of small drawers, or you want to have this one big class with everything in that.